Okay, hello and hi to everyone. Welcome to today's lesson. Okay, so today we are going to look at section C, paper 2. So for section B, usually we have calculation and we have questions regarding modification. Okay, for section C, we have explanation question, we have calculation question, and we have choosing uh, choosing question. Okay, which means that you need to choose which one is the correct specification. Okay, let's take a look at example of calculation question. Okay, this one is not in your module. I just show an example. Okay, example, as you can see, this is about chapter 2, force. Okay, so a tanker of mass 1800 kilogram accelerates from rest to a velocity of 45 km per hour in 10 seconds. Calculate the acceleration. Okay, so first, for calculation question, I always recommend you to write the info. Okay, so we have given mass and then we have from rest, meaning initial velocity is equal to 0, then we have 45 km per hour. Okay, 45 km per hour. Remember, we need to change to meter per second. Okay, it's okay, we just write kilometer per hour first, and then we have time per second. Okay, so the question first question asks you about acceleration. Yep. So from the list of information given, we know which formula to use, which is formula Vuat. Okay, V is equal to U plus AT. Okay, so 3 marks. So first marks given when you convert the unit correctly. Okay, from kilometer per hour to meter per second for final velocity. Next, so we know which formula to use. Then what we need to do, we just substitute. Okay, V and substitute U, A, and T. Correct substitution, you get another 1 mark. And last, your final answer with the correct unit, which is meter per second square. Okay, so for second question, calculate the force. So you know the formula, force is equal to ma. Now we will use mass. Okay, just substitute mass and acceleration. Okay, and we get the final answer, unit of force in Newton. Okay, usually for calculation question, first step, list down all the information given, identify which concept, identify the formula, substitute the formula, the information, and then you can find the final answer. Okay, choosing the best specification for section C. Okay, let's take a look at example. So this is regarding chapter for heat. Okay. Diagram 4.1 shows ice cream container used by an ice cream seller using his motorcycle. Table 4.2 shows the specification of four types of ice cream container PQRS. You are required to determine the most suitable ice cream container to carry ice cream. Explain the suitability. Okay. Okay, let's look at the diagram. Okay, outer box, ice cream box, ice cube. Okay. Okay, now usually this question will consist of 10 marks. Okay. So we have 1, 2, 3, 4 characteristic. Now, how do you want to answer? You just draw a table. Okay. You don't need to write this. Okay. Just write characteristic and reason. Specific. Okay, we answer the first question. Specific heat capacity of ice cream box. So which one is better? So we use high specific heat capacity box. Okay. Don't write high specific heat capacity. So the question does not know which characteristic you are explaining about. So make sure you write high specific heat capacity of the ice cream box, or in this case, high specific heat capacity box. Okay, the reason, good heat insulator. Or you can say, take longer time to increase temperature. Okay, also acceptable. Okay, for size of the ice cream box. Okay, small ice cream box, easy and more safe carry by motorcycle. Or you can say, we avoid using the word easy. Okay. Or you can say just more safe to carry by the motorcycle. Okay. Or you can say will have lighter mass. Also acceptable. Okay. Material of the outer box. We have copper, we have PVC or aluminium. So obviously we want to choose good insulator. Okay, good heat insulator. So we choose PVC. Okay, PVC plastic. Okay, as you can see here, the reason is not conduct heat. Same explanation as good heat insulator, but we change the sentence. Okay, for the first one, good heat insulator. So for this reason, you change the sentence. Okay, do not conduct heat. Or okay, if you use good heat insulator here, so you can write take longer time to heat. Also can. So basically this explain about insulator, heat insulator. Okay, color of the outer box. So we use bright color to reflect heat. Also you can say does not absorb heat. Also can be acceptable. So we have 1, 2, 3, 4, 5, 6, 7, 8 marks. So another 2. Okay. you finalize the type. So type Q is chosen because high, small, PVC, and bright. Okay. The reason, you just copy all of this back. Okay. Reason Q is chosen because high specific heat capacity of the box, small size of ice cream box, PVC, plastic outer box, and bright color outer box. So full marks, 10 marks. Okay. Okay. Second example. Okay, first identify which concept. So airbag. So obviously this is impulsive force. Okay. Diagram 2.1 shows an airbag being inflated during collision. Purpose of the airbag is to protect the driver when the car is involved in a crash. Okay. In crash? Crash. Okay, table 2.2 shows characteristic of different material. You are required to select the best material used to make the car airbag. Okay. So material, which one is the best? When it involve material that has strong but light, okay. For cloth lah, usually we use nylon. For example, material for fishing rod, fishing string. Okay, SPM question. We have fishing rod, and then the string we use nylon. Why? Because nylon is very light and also strong. Okay. Okay, tensile strength. So obviously we need to make sure it is high. Okay, so nylon, either this one. So strength. So we choose higher. Density. Density is mass per volume. So we want to use small density or higher density. We use small density. Why? Because it will be lighter. Okay. And cost. So obviously we want to make sure that it is low cost. So we know we choose type P. Okay, next we explain. Okay. Okay, the characteristic. Material product from nylon. Okay. Why? Because it is strong, or you can say it is light. Okay. Has small mass, not easily heat up. Okay, avoid using easily. So for SPM, previous years, we usually accept when we use easily, but for current situation, okay, I think last year maybe the pemeriksa tell us that not recommended to use word easily. That's why you can see many answer scheme will use easily, okay, word easily for the answer. Okay, continue. Tensile strength must be high. Material must be strong so that it will not break easily. You can change the sentence. Harder to break. Harder to break. Can harder to break. Or you can say strong. Tensile style Tensile strength must be high, so material must be strong, so it will not break, so that it will, so it is harder to break. Yeah. Okay. Okay, density must be small. Okay, lighter or to reduce mass. Low cost, reason affordable. And last we choose P because of all the characteristic. Okay, so that is how you answer section C question. Okay, this is example of characteristic and explanation. Okay, I will insert this note in your Google Classroom, so please check. Please check your Google Classroom. I will insert notes about how to answer section B and C. Okay, example. Let's see. So diameter of wire. If the question asks you to choose which diameter to use, okay, diameter of wire to use. So if you choose small, then the explanation should be do not able to sustain heavier weight. Okay, if it is big, then you can say it is stronger and stiffer. Okay, spring is about elasticity. Okay, we don't learn it yet in form 4. We will learn it in form 5. Okay, so I just want to tell you example. Okay, another example is heat. Okay, see. So melting point, for example, why we choose high melting point? Okay, so it can, the reason is melt at higher temperature or need higher temperature to melt. Okay, if you choose low, then you can write it will melt easily. Will melt easily, cannot. It can melt at lower temperature. Okay, pun boleh. Okay, specific latent heat of vaporization. Why we need it to be high? So large amount of heat for boiling, it will take longer time to boil. Okay, for example, if you want to choose good heat insulator, so good heat insulator is high specific heat capacity. For low specific heat, latent heat, latent heat. So for good conductor, heat conductor usually will have low specific latent heat or specific heat capacity. Okay, see, specific heat capacity high, so good insulator. So low specific heat capacity, hot quickly. Okay. Okay, you can pause the video and digest first. Okay, absorb the information that I give you. Okay, now we continue to question from our module. Okay, so make sure you prepare your module. Okay, for question 11. Okay, first read the question. Diagram 11.1 shows structure of jet engine. The engine produces forward thrust based on the principle conservation of momentum and Newton's third law of motion. Okay, so this is chapter 2. Okay, force, momentum. Okay, so we have jet here. First question, state the principle conservation of momentum. Okay, remember conservation of momentum. M1 U1 plus M2 U2, M1 V1 plus M2 V2. So conservation of momentum state that the total momentum before and after collision is the same. Okay, so you can answer. Principal conservation of momentum states that in the absence of external force, the total momentum of the system remain unchanged. Okay, or you can say total momentum before and after collision is the same. Okay, 1 mark only. Okay, second question. Explain in terms of the principle of conservation of momentum and Newton's third law how forward thrust is produced by the jet engine. Okay. So first, obviously, you need to know the concept of conservation of momentum, and also you need to know Newton's third law of motion. So for this case, okay, for jet engine, it is actually explosion. Okay, why? Because okay, the initial velocity for both the aircraft, okay, and also the thrust, okay, the air, okay, the air is 0. So explosion state that M1 V1 is equal to M2 V2. So negative indicates the direction. Okay, the direction of the jet engine, and also the direction of the gas. Okay, so gas will move in this direction, and the aircraft and the jet engine will move in the opposite direction. So that is conservation of momentum. Now Newton's third law. Newton's third law states that every action has an equal and opposite direction. Okay, so that is Newton's third law. So 4 marks. How do you want to explain? Okay, so look at the diagram. First, I will say the burning fuel, okay, will produce hot air and release through the exhaust nozzle. So first step that I explained that gas will be released in this direction. Okay, so that is the first step. Next, so the exhaust gases will be released with high velocity. So it will move with high velocity. So that is second point. Okay. So next, from conservation of momentum. From the principle of conservation of momentum, momentum of the released gases will be equal to the momentum of the aircraft in opposite direction. Okay, so basically this one we explain about explosion. Okay, so this is the jet engine, this is the gas, gas will move in this direction, so the jet engine will move in the opposite direction. Okay, the momentum will be equal. The magnitude of the momentum will be the same. Okay, and last, Newton's third law states that every action has equal and opposite reaction. Thus, forward thrust is produced. Okay, so here is the action, equal and opposite reaction. So this one is the thrust. Okay, so that is how I explain the situation using conservation of momentum and Newton's third law of motion. Okay, question B. Table 11 shows the design and specification of 4 different jet engines. Study the specification of all 4 jet engines. Okay. Explain the stability of each design and specification. Okay, so first one, fuel use. Which one is better? So if fuel use, we always use kerosene. Okay, you can see there's 2 kerosene here. So it's high probability that it is kerosene. Why? Because kerosene will burn efficiently. Okay, the process of combustion for kerosene, it will burn efficiently. Okay, the efficiency is very high. Okay, melting point of blade material. Okay, low or high? Obviously, it is high. Okay, so I think we found our winner, but we need more explanation. Number of blade. Okay, we want more. And size of combustion chamber. Big or small? Big. Why? Because we want to produce very high force. Okay, so we need more fuel, and the size of combustion chamber must be big. Okay, so we find our winner here, L. Okay. Okay, next we go to explanation. Okay, fuel use is kerosene. Why? Because highly combustible, or you can say high efficiency combustion. Okay. Number 2 has high melting point. High melting point of what? High melting point of blade material. Okay, state. High melting point of blade material. Okay. Okay, so explanation, can withstand very high temperature. Okay, very good. Okay, number of blade, more number of blade to increase the rate of compression of the air. Okay, bigger size of combustion chamber to increase the mass of exhaust gases emitted from the exhaust. Okay, meaning that you want to increase the volume or the number of gases particle emitted from the exhaust, so we can get more force. Okay, finally we can get more thrust, and the most suitable choice is L. Why? Because of all the aspect. Okay. Okay, so if you have any question, write it down. Okay, and please PM me. to us. Okay, C. Okay, calculation question. Boeing 747 has a forward thrust of 1 times 10 to the power of 6 Newton. Total mass of the aircraft is 4 times 10 to the power of 5 kilogram. Calculate the maximum acceleration. So we have N, we have force, and then we have mass. We need to find acceleration. So F is equal to ma. Okay. F is equal to ma, and you find the answer 2.5 meter per second square. Okay, next question. The aircraft must reach a speed of 80 meter per second to achieve takeoff. Calculate the minimum length of runway required. Okay, so minimum length, distance. So what is 85? Okay, take a look at your module. So we know value of A from our previous question is 2.5 meter per second. We know the final velocity because the minimum velocity needed to be achieved is 85 meter per second. So that is our final velocity. Initial velocity 0. Okay, because the aircraft should be stationary. Okay, and we want to know what is the minimum length, okay, to take off. So from A, V, U, and S, which formula to use? We use VUAS. Okay, VUAS. V square is equal to U square plus 2AS, and we substitute the value V, U is equal to 0. This is acceleration, and we can find, okay, the distance lah. Okay, and then calculation, and you find the minimum length. Okay. Okay, moving on to question 12. Okay, so for question 12, double slit experiment. So this is wave, light wave. Okay. Okay, let's read the question. Diagram 12.1 shows apparatus set up Young double slit experiment. Red laser pen is used as a monochromatic light source to produce interference pattern. What is the meaning of monochromatic light? Okay, monochromatic light meaning that only one color. Okay, one color, one frequency, and one wavelength. So the answer, yeah. So monochromatic light is light with only one color. Okay, or you can add one color, frequency, and wavelength. Basically, we use the same light. Okay. Okay. Question B. Based on diagram 12.1, explain the formation of bright and dark fringes on the screen. What happened to the distance of separation between two consecutive dark fringes? X, when red light source is replaced by green light. Okay, very popular questions. Okay, Young double slit, very popular question. They want you to explain how bright and dark fringes produce. Or if it's not Young double slit experiment, they will ask you about sound. Okay, how loud sound and soft sounds produce. Okay, so basically we want to explain about interference of wave. In this case, interference of light. Okay, so first, when monochromatic light passes through young double slit, two coherent source. Okay, remember, sometimes question asks you what is the meaning of coherent source. So coherent source is same amplitude, frequency, and phase are produced. Okay. Okay, to answer this question, no need like this one. You just write two coherent sources are produced. Meaning that the two sources produce same amplitude, same frequency, same phase, basically same wave. Okay. Okay, next. Superposition occur and produce interference of light. So next step, interference of light will happen. After that, interference of light consists of constructive and destructive. So which one produce bright fringes and which one produce dark fringes? Constructive interference generate or produce bright fringes. Destructive interference produce dark fringes. So this is also 1, 2, 3, 4, 4 marks we can get. Okay. Okay, that is all. Basically, we explain how bright fringes and dark fringes produce. Okay, next question. What happened to the distance between two dark fringes when green light is changed to red light? So remember Roy G. Biff. What is Roy G. Biff? So this is color red, orange, yellow, green, blue, indigo, and violet. Okay, so if green light, if red light change to green light, meaning, okay, the wavelength will decrease. Okay, remember red has the longest wavelength, violet has the shortest wavelength. So green light, okay, how do I explain? Green light has shorter wavelength than red light. Okay. Okay, next. From formula x is equal to lambda d over a. Okay, lambda is equal to ax of d. Rearrange x, lambda d over a. So from this formula, when wavelength decrease, what happened to the x? X will also decrease. Okay. When wavelength decrease, x will also decrease. So from formula, when wavelength decrease, the distance of separation between two dark fringes, okay, will also decrease. Okay, done. 5 marks. Okay. Okay, you can pause if you want to look at the answer. Okay, continue. Calculation question and question C. Okay, diagram 12.2 shows two loudspeakers. The loudspeakers are placed at distance of 1 meter apart and at a distance of 5 meter from a line PQ. Loud and soft sound are produced. Okay. The distance between two consecutive loud sounds is 1.6. Okay. Speed of sound is 340 meters per second. Calculate wavelength. Okay, so list down all the information given first. Okay, here identify what is 1 meter. 1 meter is A. Okay, look at your module. Look at the question. What is 5 meter? 5 meter is D. 1.6 meter. 1.6 meter is X. So the question want you to ask to find wavelength lambda. Okay. So we use this formula and we substitute the value A X over D, and we can get the value. Lambda is equal to 0.32 meter. Okay, next question. Frequency of sound emitted. Okay, so from this question also, given velocity of sound, speed of sound. So the question want you to find frequency given V. Okay, V is given 340. You want to find frequency, and from the previous question you know what is the wavelength, so we use formula V is equal to F lambda. Okay, rearrange the formula and we substitute the value, then we can get the final answer. Okay, either per second or hertz, both accepted. Okay. Okay, final question. Table 12 shows 4 different specifications of sound system lecture hall. Study the specification of all 4 sound system. Okay, this one is actually from previous year SPM question. Okay. So how we want to arrange our lecture hall to produce very good sound system. So position of loudspeaker must be high. Okay. Why it must be high? So it can higher than our height. Okay, so less obstacle. Okay, distance between two loudspeaker. Okay, so this one, remember. So what we want is for the value of X to be very small. Okay. Okay, I explained this in class already. We want the value of X, meaning the distance between two loud sound. Okay, it's very small. So from this formula, A is a lambda D over A. Okay. So if you want to decrease the value of X, the distance between two loudspeaker is A. So if you want to make sure that the value of X is very small, so we need to increase the distance between two loudspeaker. Okay. So greater. So look like we found our winner X, but just to make sure. Okay. We continue position of microphone. Okay, microphone must be behind the speaker. Okay, it cannot be in front, because if it is in front, then we will have feedback. Okay, the sound produced by the speaker is entering the microphone, and then it will be loop. That's why bila perhimpunan kadang-kadang kamu dengar bunyi that is a loop lah. When the microphone is in front of the speaker, that is what happened. Okay, and material used to cover the wall, so we use softboard. So confirm. Okay, sound system X. Okay, next we explain every aspect. Okay, loudspeaker located at high position to prevent sound from being blocked by the people. Okay, in front. Okay, distance between two loudspeaker must be greater. Two, to reduce the effect of interference of wave. Or you can say to reduce the distance between two consecutive loud sound. Okay, I think this one is better. Okay, to reduce the distance between two consecutive loud sound. Okay, position of microphone. So we place the microphone behind the speaker. Okay, why? To avoid feedback. Or if you don't know the term, okay, feedback, you can use to avoid microphone from picks up sound from is also acceptable. Okay, material of the wall we use softboard absorb sound. Okay, this one no need to absorb sound also acceptable. So the most suitable system is X, Y because of all the aspect. Okay. Okay, so that is all for section C. So I hope you get it. Okay, and link for attendance today will be in the description. Okay, don't forget to like and subscribe. No need lah. Okay, so if you have any question, write it down. You can pause my video, digest all the information, and then if you have any question, please don't hesitate to ask me. Okay, and that's all for today. So next week, I think we will look at paper 3. Okay. For your SPM, supposedly there is no paper 3, but for your final exam, there's paper 3 because you use all format. So we will discuss about how to answer paper 3 lah after this. Okay, class, thank you very much. Don't forget to fill in your attendance. Okay, thank you. Bye bye.